Okay, so this is going to be part 2 of the intro series for SolidWorks, and we're going to keep it simple today and just go over drawings. So if you watched part 1, you'll see that we made this beautiful piece of equipment here that we're going to make a drawing for. So I realized in the first clip, and I have not since figured it out how to fix that, but you can't see my drop down menus, so we will sort that out at a later date, but for now I'll just explain it. So you're going to go drop down new and then make drawing from part assembly. You're going to want to click that, and then this box that's going to pop up right here, it says drawing. It's going to be highlighted. Hit OK, and then I just realized my door's open, so give me a second. Okay, so now this box will pop up, and you will choose your sheet size, and there'll be a little preview window right here. Just basically pick whatever size you want. It doesn't really matter. It matters if you want specific paper or whatever scaling size, whatever. It can get a little weird on that. But if you're just working in PDFs and stuff like that, it doesn't really matter. So I'm just going to go with D, landscape D. Hit OK. And now, this is how you move around this bad boy. I always try... I learned that this is kind of new from since when I went to college, but anyway, scroll in and out, and then click the mouse wheel to drag. It's essentially it right there. So this is all your information that you can set in your settings. You can make it all fancy in here and do all your super cool documentation stuff. But if you're just trying to get something on paper to show somebody, it's all you really need is just the basics. So I guess you can click and drag this stuff, which is actually really cool. So you click and drag into the drawing, and then what this is called is a projected view. So the really neat thing about this, I'm gonna hit escape, is if I'm going back and forth between Creo and SolidWorks in my brain here. See, as I move this around, this projected view stays with it. So the reason for that is, as we dimension things, everything is going to be in line. So that way you know, and you like if you need to measure something, or if you're just observing a part as a manufacturer, it's all in line and it's not confusing. You're not like, oh, where's this lip, where's this ledge, where's this surface? It's all right there. So, and you will notice it is a standard projection. Let me see if it says it down here. No, I guess not. So there's first angle and third angle projection. And off the top of my head, I might get this wrong, Americans use third angle. And there's videos on that if you want to get into that. But essentially, all you need to do for drawing is what is on the drawing needs to make sense for who's going to read the drawing. There is tons of standards and things that everybody says that needs to be perfect on a drawing, and it needs to be this and that. And there are standards for a reason, but that's industry standards normally. If you're giving this to Joe Schmo, as long as he knows what's going on, it's not a big deal, right? So that's your goal when you're making a drawing, is to just make sure what you want done is you're able to do that. And so what I like to do though is, so here's all your stuff. Standard view, model view, projected view. Just click on this and do whatever. So I like to do projected view and then pick one of these isometric views that really shows off the whole deal. The reason I say that, yeah, see how this, you can pretty much tell everything that's going on with that. And these will be free. What I like to do, drop that in the corner there. And if you're really feeling froggy, change your view state and to where you get lines and edges and color, and it'll print just like that so you can see it. But normally, so that way we can see edges and lines clearly as we do this, let's hover over, see if it tells me, hidden lines removed. So you can do wireframe. It's normally better for, or wireframe with lines hidden. If you're doing whole, so see now you can tell this is shelled, which you I kind of screwed that up. So if you look right here, this whole thing got shelled in the previous video if you watched it, and so that's what this is saying. This all in here is hollow, so you wouldn't have known that by this or this view. So it was good. That's a good example. So now what I want to show you is just some basic dimensioning. And one thing that's kind of irritated me about, oh, also you can scroll on these things up here. So I just hover over this, and as you can just scroll. It's pretty handy. Annotation. You can do your standard dimensions. So you got to click, and you don't have to hold anything. In other softwares, you got to hold control or whatever. Oh, no, I might have just lied to you. Oh, no, there we go. There we go. What I don't like is that these are vertical, but that's because I'm used to Creo, so if you can do whatever you want. But what you can do is you can change all that. You can go to your leaders, and then, let me see, I was playing with this the other day, and all you gotta do, well, I apologize. I thought I remembered. I will probably cut this out while I screw around with this. Oh, you can hover, and then it gives you these things. So if something is in parentheses, that means it's a reference option. So, or excuse me, a reference dimension. And the reason something's a reference dimension is because you're just letting the manufacturer know, hey, this is 5 inches. It's not super duper important that it's 5 inches. So normally you would have a undefined tolerances section down here, and it would say, hey, if I don't specifically say this is plus or minus whatever thou, then this is what that is based on how big the number is. So, but if you put these in parentheses, you're basically saying, hey, it's still gonna work if this is not perfect, but I'm just letting you know how to make it. So you can kind of get your own style. I think if you double click, it gives you, oh, that might be Creo. So it gives you radius, but if you want, oh, here we go. If you want diameter, you just come in here, click. Mine always says mod diameter, and I think it's because I haven't configured my settings yet. But the cool thing is you can click this, and you come over here, and you can just delete that. But it's normally standard. Ah, that's right. I haven't set that up yet. There's a warning box right here that you can't see. But right here, this is the symbol for diameter. This is degrees. This is plus or minus. This is center line. This is up to, and this is like a counter bore, or yeah, depth counter bore, countersink, square. Okay, so center line, I can show you. But normally, you're gonna want at least put like diameter or something of that sort. Oh, you don't have to, but normally if it's a circle, you just put that in there. That circle with the slash. But so there's a couple ways to do center line. First one is just kind of hand jamming it, if you will. You just draw a line down the center. And then you can either double click or hit escape with this drawing a line. That can get a little wild sometimes. But now you can do I think it's datum feature. No. Oh, center line. Oh, that's right. There's a tool for this. I will go back on my words. Center line. And you're going to choose 2 lines in which that surface, or in which you want the center line, and then you can drag it down. And the reason you do the center line for drawing is because I would dimension this as, oh, what are we doing? I would dimension this as 2.5 inches from the center, because if I say 5 inches and pretend this isn't here, and then I say this is a diameter of 1, that does not mean, oh goodness, my computer's lagging, I apologize. That does not mean that this and this will be concentric unless you annotate otherwise. But the easiest way to do that is to just dimension off of a center line, because that tells the manufacturer, hey, this needs to be symmetric. And a good way to do that is to just put 2 times. So that's going to say, they're going to know, hey, this and this is the same as this and this, because this is a square and this is a circle. So if it's a circle, you don't have to do it because it's a radius, so it's not a big deal. And then you're going to want to do, just by standard kind of thing here, is your wall thickness. If you want to put all around or just dimension it everywhere, it's kind of up to you. But I'm not going to go through and do every single feature, but just think, if you had to read a drawing to make something, how would you make it make sense to you? So I'm gonna, this shelled kind of pocket is that kind of cylinder that we did in the first video. I'm gonna dimension that from this bottom line here, because if you do it from the top line, you're doing it, you're then dimensioning it from this edge right here to there. And that's hard to measure when you're actually making something. So you got to keep that in mind, because this surface sticks out lower than this shelled edge. So that's hard to measure, because even though this is on a simple plane on a 2-dimensional space, it's easy to observe, hey, this and this is, that's the next closest line, so I can just do that and there you go. But in reality, you're measuring from here to here, which there's actually a distance here that makes it kind of tough to measure. But I mean, there's ways around that, and obviously if you have ever machined anything, it is possible. And this would be an absolute nightmare of a part to machine, so, or even to print. So keep that in mind. But because then all you could really do is take your if you wanted to quality control your part, take your calipers, drop them down into here, you minus the thickness, you say, hey, from here to here, it needs to be 2 inches. And then you see whether or not you're within standards. So there's a lot of, this is balloons and stuff are for assemblies. There's a lot of things you can do on a drawing that just kind of depends what you want. There's a center mark, so if you need to dimension something, it's kind of a dirty trick with making drawings to like dimension off of like center points and center lines, because that's hard to do physically, right? Like it's not something you can't measure from the inside of something if there's not, like, say you have a hollow tube. It's hard to measure from the center of the circle because you don't have anything that exists there for you to measure to or from. But the way we get around that is we say, hey, this needs to be this distance from the center. So that way it keeps you in line by saying this, at any point on this circle, it needs to be whatever distance away from the center. So that keeps the machinists and everyone in check, and it also keeps the engineer honest, because he needs to make a drawing that makes sense. And so as we go into this, we can do center marks, and then I believe you can kind of move these around. And oh, maybe not. Oh yeah, you can. A general rule of thumb is you don't want your dimension line. See how there's a gap here? That's good. You don't want this dimension line and your center line to cross over, because it just looks bad. You can have these lines cross over. That's not a big deal. But when you get into a part that has a bunch of dimensions, just make sure it keeps it clean. And I actually think there might be a cleanup button. That might be Creo, actually, the more I think about it. So yeah, I'm not going to get too much into this because that's just industry standard stuff. There's tons of videos out there if you want to know industry standard dimensioning, but just to get what I wanted to show you basically in this video was, hey, I can be in the workspace of my part, and then I can just hit new drawing, boom, brings you into here, and then layout, auxiliary view. Okay, this is actually what I wanted to show you in the first video that I forgot. So I will show you something really cool. This is useful if you are trying to kind of see what's going on the inside of something, or you just really want to cut something in half. So SolidWorks, it makes a nice and easy section view. It says, hey, where do you want your section view? You just rotate or do whatever, and then you draw your little arrow, and then in here you can say whatever plane, whatever distance, whatever degree, and if you hit OK, then you can just manipulate your part like that's a feature. But in reality, it's just showing you the view. You're not actually cutting anything in half. So if you exported this, actually I don't know, I don't think it would, because it's just a view. If you exported it like this, it should still be a full part. That's just a view, because then you can just click off that, click back on that, and you're good, you know. So that's something I really want to show you, and that's a great way in a drawing to really show what's going on the inside of a part. So I'm going to move all this jazz over. Man, SolidWorks kind of makes it difficult to grab your lines here. So here, section view, and then you pick where you want the section view to be, and then it gives you a new one. And so I picked a weird spot. So the reason this is saying that this is not hollow is because I somehow got between the 1/10 of an inch of surface material right here. So it's saying this isn't hollow, but now you can see, and everything, I keep trying to show you guys how to do things with my hands, but I forget that I'm not on video. So this is just taking the part and flipping it. That's the third angle projection. If you want to look into that, it makes more sense if there's people with tons of other videos. So it takes the part and flips it over, and that's how you make it make sense in your head when you're trying to understand a drawing. So that's why you can see our sorting hat and our two cutouts, is because it took the section view and it flipped it to the, I think it flipped it to the left or to the right, whichever way you want to look at that, I suppose. But yeah, and then it also lists your section view and then says, hey, this is the view of this. So we're looking at the view from this way, if I just drew an arrow. Yeah, so essentially, that's how you can get started doing a drawing. And so if you really wanted to, you could throw this into save as a PDF. So just file, you're not gonna be able to see it because it's a drop down menu, save as, and then you can either save it as a SolidWorks drawing or a PDF, which actually, now that I look at it, oh yeah, PDF. And I'm not gonna do that because I don't need to. But so yeah, that's kind of how you can get started doing a SolidWorks drawing. Thank you.